This is a video that's going to help with completing the data analysis for the alka seltzer lab. I'm going to kind of model some of the steps that you need to do, and then you should be able to finish. So first thing is the reaction for alka seltzer. It is sodium bicarbonate plus citric acid. Those are your reactants. So I'm gonna get going with you in 1 second here. Sorry. Okay, so I'm gonna actually put the reactions on the front of the lab, but it's also helpful to have it on the back. So sodium bicarbonate. Bicarbonate is a polyatomic ion, plus the citric acid, which is given to you, the formula. Both of these are aqueous. We added water. Then we get sodium citrate, and we get carbon dioxide. That's what gives us the fizz. This is going to be aqueous, gas, and then water, liquid. Anytime we do stoichiometry, we need the balanced equation. So we're going to need a 3, I got that one, and a 3. So if we look at the data, the mass of the tablet, my data, is 3.33 grams. And then the mass of the beaker with the water is 69.67 grams. So this is going to be the total mass before the reaction starts. And then this is the after the reaction, after the CO2 leaves. So total mass of the tablet is going to equal, the mass of the tablet plus the mass of the beaker and water, which is 3.33 plus 69.67, which, like I showed you up above, is 72.81 grams. So then we can figure out how much carbon dioxide was formed by taking 72.81 and subtracting 72.30, what we had at the end after we let it all bubble. And for me, I get 0.51 grams of carbon dioxide were produced. So what we want to do, though, is convert that into moles. So I can use the molar mass of carbon dioxide, which is just the carbon, 12.01, plus the 2 oxygens, which are each 16, so plus 32. So I get 44.01 grams of CO2 in 1 mole of CO2. So when I do this, I get 0.012 moles of CO2. I'm keeping my sig figs. I started with 2 and I'm going to end with 2. So then when I get to the back, what I'm going to do is I'm going to always start with that amount of CO2. And then I'm going to be looking for, I'm going to calculate the amount of grams of each of the other substances that either reacted or they were produced. So I'm going to go for sodium bicarbonate this time. Sodium bicarbonate is right here. So I'm going to do a mole-mole ratio where I'm going to use the carbon dioxide moles, which we can see as coefficients. So there's 3 moles of CO2 for every 3 moles of sodium bicarbonate. And then I'm going to do one more step, and I'm going to then convert to the known amount of grams by taking the molar mass. So you don't have to show your work anymore for those. 22.99, 1.01, 12.01, and 16 times 3. That gives us 84.01 grams of sodium bicarbonate per 1 mole of sodium bicarbonate. So when I do that, I do want to answer with 2 sig figs. So my answer is 1.0 grams of sodium bicarbonate. So essentially, you're going to do very similar for the next questions. So I would again start with the 0.012 moles of CO2, and then I'm going to do another mole-mole ratio and another molar mass, and this time it's citric acid, which is right here. So I hope that helps. You should be able to finish it up, and then that's it.